Hello everybody, this is Eric Colburn and we'll get going with the DataMate Live webinar series, Surveying with Small UAVs, a Paradigm Shift. There's a little window on the side I'm being told that's in the way. I'm moving that. Okay. No sound yet I'm hearing. Can anybody hear me? Can you hear me now? All right. Some people can hear me. That's good. Thank you for responding. I appreciate it. Okay, so we are recording this video, so it will be available at the end after we do a little bit of processing at the end. Do a few little introductions and we'll get going here if everybody is ready. Okay, so again, this is the DataMate Live webinar series. This is our second of our monthly webinar series, and this one is Surveying with Small UAVs, a Paradigm Shift. I'm Eric Colburn. I'll be presenting. I'm president of Colburn Strategic Partners. All right, what's going on here? Just give me 1 second. Having one little temporary difficulty here. Just bear with me for 1 second. There we go. Everything's working now. Sorry about that. A little bit about DataMate. DataMate is the leading vendor of field-to-plan software products. There are hundreds of customers. They're mostly land surveying firms, and that's actually the target market for DataMate, is software to help surveyors work better and safer. The founder and CTO is Jad Jarouche, PhD, and co-founder and CEO is Chaim Zelakovsky. I'm Eric Colburn, the president of Colburn Strategic Partners and ericcolburn.com. And helping me today is Tony in the background, which I appreciate very much, and he will be trying to answer your questions as well as I will when I have a moment. But with that said, do submit your questions. We just might need to, at the end, compile those, and we'll get back to you with answers if we don't do it live during the webinar through chat. Okay, so the outline of this webinar is we're going to review Datagram 3D, which is a close-range photogrammetry software. We're going to go over some UAV basics, some tools, rules, and news. We're going to learn a little bit about the practice of using UAVs in close-range photogrammetry surveying and mapping. And along the way, but we'll have more at the end, but I'll intermix a few throughout the webinar just to break it up and keep it interesting. We'll have some real-life case studies showing land surveying projects using UAVs. Okay, I see somebody lost sound. Hopefully they'll get it back. So the agenda for this webinar is, again, we're going to talk about close-range photogrammetry review. Just a quick review, some UAV basics, rules, use in the field, real-life surveying case studies using UAVs, and then we'll wrap it all up. Having some difficulties here again. Excuse me for 1 minute. I don't know why the screen keeps locking up. There we go. First of all, let's talk a little bit about, and we'll go through this quickly, what is photogrammetry. So we're talking about obtaining reliable information about physical objects and the environment from photographic images. I think we're all, hopefully, many are familiar with. I'm just making sure. I see some people can't hear. I'm not sure why that is. On my end, everything looks good. We're talking about, I'm just going to put out a little message to Tony. Tony, can you hear me? Just sending him a little message as well. Okay, so at least some people can hear me. If others are having issues, they can't hear me to even figure that out, but hopefully they'll resolve the sound issues. Okay, so we're talking about specifically in this webinar, photographs made from an airborne platform, being a UAV, and specifically to close-range photogrammetry. We'll be talking about that, but typical photogrammetry, or what we would call conventional photogrammetry, there are oblique and vertical photographs. Typically, they would use a dedicated metric camera system, which is very expensive and complex to operate, rely on known position of the orientation of the images, and they provide a medium level of accuracy. And again, that depends on the camera and their height. All right. Close-range photogrammetry, the different types. We're talking about a different paradigm where photographs are made by surveying crews. They're made from ground or near ground level. They're using regular digital cameras and inexpensive ones at that. There's no need for position and orientation of the images themselves. Again, as I mentioned before, they're cheap to use and simple to use. With the new software that's out there, we can provide high levels of accuracy of 2 centimeters or better. So it's really good for your everyday surveying needs. What I'd like to do is switch over and show you a real case study using Datagram 3D, which is this case study number 1. Oh, good. I hear people can hear me now. I'm back. That's good. And the reason I want to do that is we find quite often that users, surveyors, mappers, GIS professionals may not be familiar with this type of photogrammetry solution that's out there like Datagram 3D. And so I just want to run that through you quickly to show you how that works, but also it really lends itself to showing you the first case study, which is roadway mapping. In this case, the task was to survey a road, traffic markings, overhead signs, and street lighting structures. Very traffic-intensive road, so occupational safety is also an issue here. They had planned conventionally 5 days of work, 3 in the field, 2 in the office. And by using a UAV and Datagram 3D in a close-range photogrammetry solution, they did the entire job in 1 day, half a day in the field and half a day in the office. And I will mention this several times throughout the webinar because it's one of the questions we get asked often is, I'll try to let you know when I know what was used on these projects, but one of the questions we always get is how high is the UAV? Or I guess put more correctly, we often get presented with the assumption that it has to be flown very high. So that's not the case, and in most cases you want to be reasonably close to the ground to get higher accuracies with these cameras. And we'll go through the equipment and the cameras a little bit later in the webinar. But this is a good example of the UAV was flown about 15 minutes in the air, and I'll show you the images in a second. And it was only flown 50 to 75 feet in height. I don't really know all the elevations, but you'll be able to judge throughout it. Some are a little higher, some are a little lower. But in general, most of these are flown at about 50 to 75 feet in elevation above ground level. And in this case, they used a Sony Alpha NEX7 24 megapixel camera with a 16 millimeter fixed lens, and it's mounted on a quadcopter. Oh, it does say it right there. It was at 50 feet and was Wi-Fi controlled. So let me get Datagram 3D running and show you this project. So when they were in the air, they took 27 images, and they likely took more than 27 images, but we're using 27 images, and they flew around. There is a linking process that takes just a little bit of time, a few minutes, and for time limits, I'm not going to show you. It's already been run. Going to turn on the names. So you can see they flew around. I'm going to go about every other picture. And they flew around the site with the UAV at 50 feet, taking pictures, okay? And they had a couple of pictures sort of directly overhead, okay? Let's go back to the beginning. And then there is some surveying required. So, just reading a message here. Okay. Everything seems to be coming through okay. So one of the key things is you do need surveying. So they had done some conventional surveying on the ground to locate some anchor points, which is what you're seeing with these orange point markers. So they located corners of signs, traffic markings, like the endpoints, tips of arrows, even some window corners and building corners and things like that. Here's some more traffic signs. And we'll go through a little bit of that technique. That's really not what this webinar is about, but it's important because it's what makes everything work. And then once it was anchored, ran a quality check. Datagram 3D uses a red light, yellow light, green light system as a warning system. Green light means good, you're ready to go. So we have very high accuracy results here in anchoring the images. And then we go to the new points. So this would be the process after you have everything anchored and ready to go. And we can select layers, create layers on the fly. We can create points, polygons, and polylines. I'll create a polygon. Let's just zoom in here. And again, I'm not going to belabor this, but some people have not seen that this is even a possibility. We click on the screen. I'm going to draw this arrow, give it a name so I can find it. And then what the software is doing is I click on this one image. It's finding that same pixel in at least two other images. And once it's done that, it turns green, which you can see here. And now they're all going to go around. Hopefully they all turn green. And when it's done that, it means it's extracted a full 3D coordinate value for those points. So they've all turned green. Let me find this object. Hold on here. So I'm going to highlight that object. And then we can look in another image and we can see that it's projected correctly on all the other images. Where else we might see it. Here it is from a distance. Okay. So there's that arrow projected on the other images. So this is really a game changer in working with close range photogrammetry with regular cameras and using Datagram 3D. And then finally, just quickly, we'll just look through. We'll find that same thing I just drew. There we go. It's up at the top. And we can see that it's got accuracy. It found it in multiple images, more than 3. And their accuracies of about 0.02 of a foot. So it's really highly accurate. And then just quickly, there's some reports that show the results. There's a 3D viewer. Okay. And there we go. You can see everything is drawn in full 3D. Okay. All the lights, all the poles, all the stripings, the curbing, things like that. And we can export point files, DXF file to your favorite CAD software. And there's also an option up at the top right-hand corner with AutoCAD Connect feature, which is really cool. You can connect it right now to AutoCAD 2014. And then whatever you draw in the new points, real time will show up in that CAD drawing and vice versa. So it works both ways. If you draw something in the CAD drawing in 3D, it will automatically be, if it's in the right coordinate system and it shows up on the images, it will be projected geographically in the correct location on those images. So again, so that's just a quick review of Datagram 3D because, again, we find that a lot of surveyors may not be familiar with the fact that you can even do something like this and develop new points in full 3D. How many control points we use to anchor this intersection? So there are a lot here because this was, well, there's not a lot, but there are more here than you actually probably need because this was done in an older version of, older release of Datagram 3D. And at that point, you needed anchor points on every image. You don't need that now with the, go back to this first screen with the anchoring of the images. It reduces it now so that you only need 6 to 10 maybe as a minimum. You probably would use more, but 6 or 10 control points to anchor it. And they don't have to be on every image within a cluster of images. So in this one, just to give you an idea, and I know there are probably more than are really necessary. There's 1, 2, 3, 4, 5, 6, 7, 8. Yeah, so they probably used about 20 altogether on this, but I believe that's because this was done in an older version, so it just got carried through and updated. All right, so there's Datagram 3D, which is really, once we fly a UAV, we have to do something, and that's always been an issue. We have to do something with those images. So let's go back to the presentation. Let's talk a little bit of why now. So, the why now is that there's been a real revolution in digital photography, largely driven by smartphones. So we have high-resolution cameras are really a commodity now in the 20 megapixel range, and that allows for 2 centimeter or better accuracy at a distance from about 100 meters or so. And then also coupled with the rapid evolution of office computing, where the computers really are very fast with high-end processors in them now that they can easily process, I don't know about easily, but they can process the complex algorithms that are required to make close-range photogrammetry work like this. But ultimately, at the end of it, really also is this is being helped by UAVs. There are a couple of, there are different platforms that you can use to collect the photogrammetry, and I'll go over that very briefly in the presentation. The other options, because I think it's important to know that UAV is just one tool that's available to you, but the consumerization of that UAV has really made this an efficient process that's available for surveyors to use and to use efficiently. So, prior to this, we'll call it today, but it's really getting to be the past at this point. Conventional surveying is, pretty expensive and labor-intensive, complex, error-prone. You're taking field measurements and sketches and putting it together with a drawing of map. With close-range photogrammetry, we now have a new field-to-plan process using regular cameras. So we just photograph the surveyed area of the object. And again, there are different ways of accomplishing that we'll go over. We georeference the images, which is why I wanted to show you that last example so you can see the anchoring process there. And then we measure and draw directly on those images, getting full 3D results. Right? So we're drawing right on, and this is an example I'll show you. I think this is the last case study, an industrial area. Oh, this is several different case studies. I'm sorry. 3 of the pictures are in part of this industrial area, which is case study number 5, and then the upper right-hand one, I believe, is another case study, which I won't be showing you, of a small urban area that was mapped. But all the drafting was done right on regular images from just an inexpensive camera. So the value of close-range photogrammetry to surveys is really huge. It's really a huge increase in productivity that saves you field time and office time. First time, right, no need for follow-up work. If you need to measure something and it's in the images, you can just click points on the images and gather that extra data instead of sending a survey crew back out there. Really faster turnaround times. We've seen that with some surveyors offering at a premium next day delivery. Exceptional quality control. I didn't show it to you. Let me bring back Datagram 3D because I think this is really an important issue. But you can take your survey control, the conventional surveying, and we can select them all. And we can project those points, which are these little arrows. So if you can see point number 14, which was the tippity top of that sign, that's your conventional surveying points projected onto the screen. So you can mix and match your conventional work with your aerial and Datagram 3D work and be able to prove where those shots were actually taken visually, which is really a lot easier methodology than trying to figure out from field notes what happened. And then lastly, and really important, are occupational safety issues regarding OSHA, but also traffic. Not having to go out into traffic or high-risk areas is really important, which is a huge benefit to using close-range photogrammetry. So let's talk a little bit about some of the basics, some of the terms, tools, and equipment of UAVs. Getting a little message here, just reading it. Excuse me for a minute. Just going to write a little answer here. Okay, so what's in a name? You'll see a lot of names for UAVs, and I'm using the term UAV, but sometimes you'll see them referred to as drone, UAS, or UAV. So unfortunately, the left-hand picture is what many people think of when they think of a drone, which has a negative connotation due to weaponized uses, where the military is using drones to facilitate pilotless aircraft that can kill people. Unfortunately, I think drone's a really good name, and as much as it was sort of negatively associated with the industry in the past, I do see it being adopted more and more. A typical name you might also see is an unmanned aircraft system, UAS, or as I'm calling it in this presentation, a UAV, unmanned aerial vehicle. And I ask, why not flybots? Although I really like drone the best. So I may slip in a drone here or there, but we'll try to stick with UAV. And what we're talking about, a very small, unlike the militarized drone on the left, on the right-hand picture, you can see a couple of DJI UAVs. A lot of acronyms there. And they're very small, lightweight, and easy to fly. So we'll talk a little bit about the UAV whys and whats, a little bit about cameras and lenses, although I'll introduce you to the term sensors, which is what's more and more being used in the industry, and I'll explain why in a minute, but we'll mostly be talking about a specific sensor being a camera. We'll talk about tools to elevate the camera, mostly about the UAV, but I will introduce you to some other options. And again, a little bit about, we've already gone over, Datagram 3D, which is the close-range photogrammetry software used to process these projects, but a little bit about what's important to look at when purchasing a close-range photogrammetry software. So why UAVs? Well, first of all, they're easy to use. They come from an industry that was geared towards the consumer. I see somebody also says they're called RPAs, Remote Piloted Aircraft. I think I like that too, RPA. I'll add that to the slides. Pat says it's a new term used in most countries. So I did not know that. I will do some research on that and I'll add that to the slides. They're easy to use. They're more and more having built-in safety features added to them because they're geared up till now largely to the mass-produced for the consumer, although that's changing. They can be inexpensive, although some are not. Some can be very expensive. But ones we're talking about are on the lower price end of the spectrum, anywhere from $1,000 to maybe $5,000, depending on size and equipment you're adding to it. Very efficient data collection methodology. It just, in 15, 20 minutes, even in 10 minutes, you can collect so many images. And so it's very cheap and efficient way to work. I think it's important too, because I think it opens up new business markets for many of you. And these are just a few of these. A lot of this I got from a partner of ours that makes UAVs, GeoBlue. I think it's geoblueservices.com. And they have more, actually, uses on there that I think could be available to you, but I've limited it to these. So first of all, it's just aerial surveying. That might be something that you subbed out to an aerial surveying company in the past. For smaller projects, small to medium-sized projects, you can do that yourself now. Definitely if you're going to be going out and doing something that's hundreds of acres or 10 to 20 miles of road, I'm not saying that you couldn't do it with Datagram 3D. You could, but you'd break it down into smaller pieces. There is, at some point, you're going to go with a conventional aerial surveying firm. But if you're doing small sites, small commercial sites, or stretches of road that don't go on for, tons and tons of miles, you'll be able to do aerial surveying yourself. Building facades, not necessarily a use for UAVs, although it could be, but works really well with inspection. So this is something that could be coupled with measuring, like I showed you in the last example. In that case, we're measuring a road, but maybe it's inspecting smokestacks. And not only are you providing visual data to your client, whether that be pictures and video, you might be processing that data with a little surveying to take measurements, maybe measure cracks or just the location, monitor it, whether a building's moving, things like that. Agriculture, they are using UAVs a lot, and that is definitely something that you might find a little niche that you can get into depending on your locale. Environmental issues comes in great for mapping environmental issues, so that there might be work that you did not do before that you could do. And also because of the safety nature of it, that you don't have to go into hazardous areas. I didn't put hazardous areas on there, but I think that's a possibility too. Emergency response, maybe you could get into accident reconstruction, things like that. And then, even wildlife habitat analysis. Maybe there's some sort of biological business that you could go into and provide services that weren't done before. One of the other things was on the list was search and rescue. Now, that's probably not something you would charge for, but if you already have the ability to fly, use these sensors and mount them on your UAV, whether that be visual or some sort of a thermal sensor, you could at least provide some benefit to your community. It might not be a business venture, but it could be something that you could give back. Going on a little bit more specifically about UAV equipment, you'll find that there's a range of copters. So you can get quadcopters, hexacopters, octocopters. The more propellers you have, you can carry and have heavier lift packages. So if you maybe can provide more battery power on that UAV, it can fly longer. Or depending on the weight of the camera or sensors that you're using, that can become a factor. The bigger the copter and the power supply on it, the longer the flight time. So you might be able to collect more data, and you'll have a little bit more stability in stronger winds. Now, most of the projects today I'm showing you were done with a quadcopter. We have used an octocopter, and really not a huge benefit for most small projects. It's when you start to get into maybe a little bit of a bigger project where you need to be up for a longer period of time taking pictures, or you want to fly in slightly stronger winds. I don't recommend flying in stronger winds. That's not what I'm trying to say. I just want you to be able to know that that's an option that can help you out. There are other options too with UAVs. They can be planes or look like planes. I've seen balloons, all kinds of different options. But in today's talk, we'll strictly be talking about the quadcopters for the most part. Part of that is you need to have something that holds the sensor, or a camera in this case, and that's the gimbal. Okay, and that allows the camera to be tilted and turned independently of the copter itself. You have the sensor, which is a camera, but you can get thermal and other sensors as well, which can come into play with agricultural uses. For instance, they can look at the soils and determine how dry they are and the crops and things like that. But we'll be talking about using a regular camera. You'll need and these all come in a package, but you'll need a flight controller and a transmitter that will communicate with your flight controller to the UAV and the camera, which means that there is some sort of radio or Wi-Fi involved. And lastly, I don't know why I put it on last, because it's really very important, is GPS. So I think almost all of the quadcopters I've seen, or different copters, have GPS. That's how they figure out where they started from, and they have a return to home feature. It's just important to let that go through the process to establish its location before you take off. Follow the user manual. But that's a key component to the working of these, and while you'll likely be flying it through line of sight, you can at some point, with some devices, you can program them for a flight path and things like that. And they're getting very sophisticated. There's a video on YouTube with, I forget how many small little copters, very teeny copters. The guy is flying in a room. He had a screen up so he didn't hurt the audience, but they were all communicating to themselves independently and figuring out their location. So these things are getting really smart and safer as we go along. I think there are some other really important considerations to take into account here. And one is training. So I think it's really worthwhile to get some professional training. But in lieu of that, and it might be mandatory where you are. That's something obviously to take into account, and I'll mention that in a minute. But if you're not getting formal training, definitely take the UAV to an area where you're not going to hurt anybody else, and hopefully not yourself, or damage anybody's property. And practice until you're really confident that you know what you're doing. Insurance. So using them for a commercial purpose, I guess regardless, but as a commercial purpose, think of it like your general liability insurance. You can now get insurance for flying UAVs, and I think that it's not expensive. I think that's a very valuable thing to do to safeguard yourself, because these things could hurt somebody if they were, and will damage property if they crash. A couple of considerations. Most of them come with extra propellers in the kits, so that's maybe not a problem. But having extra propellers is really handy. You are likely to have some minor crashes as you're learning to fly these, and the propellers are they're the weakest link in the chain, but they're easy to switch out and add new ones. I think the really key thing is extra batteries. If you're out on a job and you go through and you fly for 10-15 minutes and it comes back and lands because the battery power is low, it's nice to either have a charger on site to charge it, and or an extra battery to throw in to continue that. Now, most of these projects, the images were collected in 10 to 20 minute range, but first jobs you might be a little more slow with it as you're learning. So definitely have those extra batteries. And if you're doing multiple jobs a day, then you'll want a few extra batteries. And then lastly, I think is really important. I don't know, being a surveyor, I've never liked loose equipment. If you can get or make a travel case to hold everything so it's not getting banged up in the back of your survey truck, I think is really a good idea. A little bit about choosing a camera and lens. So I mentioned this before. We're talking about 18 megapixel or better cameras. I think most of the ones you'll see in here today are 20 or 24 megapixel. The better resolution allows for higher accuracy. We do recommend using a wide-angle lens, which gives you a larger field of view, crisper images, less weight. If you're using it in a UAV, that's really important. Most of these cameras come with a 20 to 50 millimeter lens, for instance, which is pretty big, maybe twice the size or more than the size of the fixed 16 millimeter focal length. But the real key thing is that if you get what we recommend, or smaller, a 16 millimeter focal length, you'll see one of the cameras actually, I think, has a smaller one than that. But if it's fixed, your field crew can't accidentally change the focus, which will mess up the software later. So a lot of good reasons to go with that fixed wide-angle lens at a 16 millimeter focal length. Let's see. So these are just a couple of examples, not recommending any of these cameras at all. And really it's a function also of the UAV that you're purchasing and the gimbal that comes with it. So you have to match everything up to make sure that your camera will work on that gimbal. But, Samsung NX3000 is a 20 megapixel camera. I use a slightly older version than that. The Sony NEX7, which is that's the one I was used in the last case study I showed you. The Samsung NX Mini is a 21 megapixel camera, and I know that has a shorter focal length than 16 millimeters, but I don't remember what it is. I think it's maybe 9, I'm not sure. So you get a wider field of view. And then there's the Sony A6000 24 megapixels, which is a good camera. So the key is you want to get interchangeable lenses, 16 millimeter or less fixed focal length, and they're compact, high resolution. They're not very expensive. Most of these cameras are around $500 or less, although the added lens cost a few $100s, but it's well worth it. A little bit about what we're really doing here. I think it's worth remembering is that we're trying to, the reason we're using a UAV, other than it's fun to fly around, right, is we're trying to elevate the camera above ground level, because we want to minimize foreground obstructions that would hide the features we're trying to survey, fences, vegetation, cars, things like that. But there are other options. So you can take the picture from the rear of a truck, get a little bit of height that way, from a tall building off the rooftop. We've done it that way. Using a telescoping pole, very good way of working. And then lastly, what we're talking about here is a mini quadcopter. And the reason I bring this up is that I think you will use all of these methods. Even if you have a quadcopter, which if you can use, you will use. If it will be allowed on the site that you're going to be able to survey, you'll use it. It's just a great way of collecting that data. But there will be times where you'll have to use a pole or one of these other methods. So it's good to know that you're not locked into just using that UAV. And this is an example of a telescoping pole. So there are more sort of handmade ones on the left, and then working towards, or the two in the middle are really professional poles that are created by photograph companies. That's not the right word. And I think the third picture is a rod that was put together by our partner, GeoBlue Services, if I'm not mistaken. And then the last two, the little pictures on the right, are really fully automated pneumatic poles that can go up quite high, 60, 70 feet or more. Can be mounted, not can be, I think have to be mounted to your vehicle or an ATV. but you can do everything remotely right from that vehicle. So again, there are different tools. UAVs are just one of them. And then, of course, we're talking about deploying mini quadcopters, and they're really highly effective for surveying. Small, lightweight, simple to operate. And the key to it is, and this is important when you're buying a camera, that they can be controlled Wi-Fi through your smartphone or your tablet, or whatever the controller is for the UAV, but typically it would be a phone or a tablet added to that. You need that Wi-Fi capability. So deploying mini quadcopters, I guess really the key thing that I want to impress is safety, safety, and more safety. I think you need a heightened and focused situational awareness, so you have to evaluate site conditions and obstructions, make sure you're flying above utility lines, for instance, and that's true with a pole too. If you're putting that pole up, you have to look out for electrical shock from overhead wires. We do need to consider weather and wind speeds. We want to maintain a line of sight. Most importantly, I want you to read, understand, and follow the UAV manual. There are a lot of settings, well, not a lot, but there are settings that you have to set on the UAV or the controller. For instance, there's a condition called flyaway. If you don't let the GPS ascertain your position and record that, it might try to fly to the last place it did so, which can crash your UAV in ways that you did not anticipate. Flight planning and required heights. So we're going to go over the rules in a minute, but avoid known prohibited areas, airports, military bases, etc. In the U.S., there are standards by the FAA that you definitely have to follow for that. I do have a map, but I couldn't find it. When I do, I'll send you people the link to that. An interactive map that you can plot your location to see if you're in any of these known prohibitive areas. Determine your local rules and follow them. And then again, as I mentioned before, most of these flights are not very high, 50 to 75 feet, maybe 100 feet at the tops. You definitely don't want to be flying at 400 feet or more for legal reasons, perhaps, and also practical reasons. And then lastly, if you have to use these images in some sort of a software package, you want to evaluate close-range photogrammetry software packages. You want to make sure that it can have survey-grade measurement accuracy, that there's automatic camera calibration process, which I did not show you. That was, I think, mentioned in our last webinar. Very quick process with Datagram 3D, but some software packages you either have to send out for that or pay extra. That there's automatic image association and orientation, that you can automatically find new points in images versus creating a lot of points and then processing that for several hours, that you can draw directly on those images, and that it integrates with CAD software packages. Ultimately, you're probably doing your final surveying and engineering plans in your CAD software, so it needs to integrate tightly with that. All right, let's look at some rules and news very quickly because this is changing. Know your local regulations. So I know we don't have everybody in the webinar from the U.S. Hopefully the country that you reside in has already come up with rules and regulations to follow, but the United States, for whatever reasons, has not. But even given that, there can be overlapping rules and regulations. You can have city and town and county laws, rules, and regulations. Usually more geared towards privacy in those cases, even with state laws, rules, and regulations. And then federal laws, rules, and regulations, whatever they may be in your country, you need to discover those and follow them. We'll go over the FAA in the U.S. in a minute, has given conflicting, or there's been conflicting information on that. But the key issues really with all these rules are safety, liability, and privacy. I think while we've always done aerial photogrammetry, I think the public's just starting to figure that out. So are non-commercial users really safer? So the FAA claims that if you're using a UAV for a non-commercial use, it's perfectly acceptable, but for commercial use, it's illegal. And I'm going to oversimplify their position. For identical use in equipment, non-commercial use is okay, but commercial use is not okay. I mean, using this logic, you can have an 8-year-old flying that UAV around for fun, and they consider that safe, but a surveyor flying the identical UAV in the same exact way, and maybe even safer, is somehow a danger, and that just doesn't make any sense. And along those lines, there have been a couple of court cases involving the FAA, and which are listed here: Rafael Perka versus the FAA and Texas EcuSearch versus the FAA. The EcuSearch ruling wasn't strictly about their rules and regulations. It was more about the process that was used. But in both of these cases, the judges ruled that, or mentioned, one ruled, one mentioned that the 2007 policy memorandum that the FAA is claiming that you can't use UAVs for business purposes were found not to be legally binding. So with that said, and a little bit of ambiguity there, the good news is that the FAA is soon to release rules and regulations for commercial UAV use. They plan on having some very basic rules out in the next month or two, likely to be for UAVs under 55 pounds, which is what we're talking about today, with line of sight flying only. I'm sure there'll be other conditions that they add to it. And then they'll be adding to that. They do have test sites around the country and the U.S. that they're gathering information about safely using these devices. And they'll be coming up with more formal rules and regulations. But we do plan, they say they're going to have some basic rules out before the end of the year. So let's just talk a little bit about UAV use in the field. So in this case, we have an intersection. What you're going to do is to fly around the outer edges, if you will, of that intersection, taking images towards the center. As I showed you in the first example, you're going to then conventionally measure a few control points. Somebody asked if you can get the PowerPoint. Sure, we'll definitely provide that for you. They might require a commercial pilot. Somebody just asked that with the FAA. Unknown at this point. I don't think they will. So we want to just talk just quickly about why this is working. So, what we're doing is, for any point we want to create, it has to show up in at least 2 images. So you do want a good overlap of the images. And Datagram 3D requires 3 images for redundancy purposes. And so you want good angles between them. This is really just surveying 101. We talked about the lens before. We just don't want to change the focal length of that lens in the middle of the process. That would not be good. So specifically now, if we're looking at surveying a road with a UAV, we're going to divide that long road into sections about 750 meters in length, and you're going to take 20 to 30 consecutive images from both sides of the road, and you're also going to take some images directly over the top. So you can see at the bottom there's a path in the yellow line. You go up the middle, around the bottom side, around over to the top side, all looking towards the center of the road, if you will. So we get some oblique angles from the outside edges, both edges, and then some directly overhead. And we want to do that in a way that, minimizes obstructions, obviously, if possible. And then we want to modify the elevation of the camera between the images, which is important for the accuracy of the software. And it doesn't have to be modified much. A few feet is more than enough between images. Yeah, we went over this before about elevating the camera. Again, we're just talking about getting beyond obstructions or above obstructions. It's really important that you slightly vary the camera's elevation at each image. That ensures optimal measurement accuracy. And then it's also important to take your images in consistent lighting conditions, so that preferably we recommend taking them at the same time of day, so there's not a huge change in the sun's location. Got 3 examples at the bottom here Again, the middle one is the intersection, the right-hand one is the street that we talked about, and the left-hand one is a building facade, which is really not what we're talking about today. But maybe if you were flying something and it had a flat surface like a building facade, you would use the same method of more or less focusing on the center of that and then taking a bunch of angles in a set direction along the face. We do recommend taking 20 to 30 consecutive images with good overlap. That really adds to the redundancy and the accuracy within the software. Again, talking about the intersection, go around that perimeter every few meters, take an image flying the camera around. It shows little cameras here, but you imagine those attached to the bottom of a UAV. Again, modify that elevation between camera images. So what we can do is look at a street intersection here. Just a few case studies that are coming up, but I just wanted to break it up a little so that it didn't get too boring. All right. So this is another example or case study of a street intersection. And we got only 17 images in this. Okay. And they just flew around, as I mentioned to you in the prior examples, just flew around that intersection at about 50 or 60 feet above ground level. Okay. So really 10, 12, 15 minutes imaging, that's it. They anchored it, okay, and then drew all these new points, and not going to belabor the process here, but you can see here's a full 3D example of the results drawing that entire intersection using a UAV. So they had planned conventionally 3 days in the field, one office, 3 days altogether, and the total project using a UAV and Datagram 3D is 5 hours, so a huge increase in productivity. Whoops. Just a little bit about georeferencing too, and I think this is sort of photogrammetry 101, but you want easily unambiguous, easily identifiable control points in the field that you match up to the images. You know, like that dark spot on the left with the oil spot is not a good point, but tips and angle points and arrows, tops of signs, corners of buildings or window trim work excellent. We can't stress enough that you're never going to be more accurate than your own survey control. So you need to take these georeference measurement points as accurately as you can or that you need to for that project. Also, just a couple of little background information on control points here. Again, this is sort of like putting in good control when you're surveying out in the field. You don't want to clump it all together. You want to spread it out, the control points, and you want to make sure that they're on more than one plane. If they were on one plane, it would be very inaccurate. So you want to mix it up for height and depth, if you will, sort of box in that area that you're surveying with good control. And then I think it's really important that we mention that there are limits to using close-range photogrammetry. You have to be able to see the images, what you want to measure, so there can be challenges with vegetation, traffic, and fences. You have to see the object in at least 2 images, 3 with Datagram 3D, which is pretty easy to do with the overlapping, but obviously if you're in an area with a lot of obstructions, you're going to have issues, and you're going to need to locate that conventionally with your total station or GPS. And there have to be some kind of feature on the measured object. However, actually, I got to change this last line. Featureless piles of industrial grade material is true. Something that is so homogeneous that it doesn't really have a difference from grain to grain, for instance, would be difficult to work with this. But you can, with version 3.3, which I've been showing you, you can create manual topo points on the ground And then version 4.0, which is due out shortly, within a week or so, there'll be an automatic topo points feature that will do automatic surface extraction. So if you're measuring stockpiles and things like that. So we only got a few minutes left here. Let's just look through some real life case studies. Got 3 more to go. This is a pedestrian bridge, and they had planned this is a divided highway. Definitely not something you want to be out walking across. They had planned 3.5 days altogether for conventional surveying, and they actually did it using a small UAV with a Canon Rebel 650D 24mm fixed lens in 5 hours, 1 hour in the field. And I think that's really critical here, right? 1 hour in the field, both flying and taking the pictures and shooting the control points. So that's pretty amazing. Let's just take a quick look at that project. So they were in the air, again, about 12 to 15 minutes. They took we're using 27 images. They may have taken more than that. Some anchor points that they shot reflectorless on, signs and things that they could identify. There was an issue with the material on this pedestrian bridge that does air temperature have much impact other than on batteries? I think mostly it's a battery issue, but definitely you'd have to check with the manufacturer. Somebody asked that question, I'm sorry. You definitely have to ask the manufacturer as to what the limits are, both hot and cold, I would imagine, both from an electronic standpoint and the little electric motors that make the propellers go round and round. Back to the pedestrian bridge. Whatever this material is on this bridge would not always return reflectorless measurements, so they were more or less forced to use alternative methods. And there it is with some new points. They didn't do a lot of crazy work on this, but they got the general shape of it for clearance purposes, and you can see it right here in full 3D. So, not bad for half a day's worth of work, of which only an hour in the field, and it was a lot safer. Case study 4, and again, this is something that maybe in the next webinar we'll be touching on, is a stockpile. This was done using manual topo points, which I mentioned a minute ago. 2 days in the field, they had planned conventionally, and they actually did it again in about 5 hours, 1 hour in the field and 4 hours in the office. This is something that will really revolutionize the way you work if you work with stockpiles with version 4.0, because you'll be able to do automatic topo points. So whereas in this version, they had to manually click on all the points to create the surface. So what do they use here? 33 images. They anchored a very small handful of points, and then they drew all the topo points on, manual topo points on the surface. In version 4.0, there'll be another button over here in the new points that you'll just give a bounding sort of polygon around to constrain the calculation. It will automatically extract, and you'll tell it the density that you want. It will automatically extract that full 3D surface. But you can't do it manually right now. It's just going to be much more efficient in the new version, okay? So there's another case. And again, they were only flying about 50 feet, 60 feet in the air. I think that even looks closer to 50 than 60. All right, one last one here. We're running a little bit behind. Case study number 5 is an industrial area with, this is not small, 6.5 kilometers of road or different roads, but of road in an industrial area. They expected 25 days conventionally to do this project, but that's 15 days in the field, 10 in the office, but that 15 days in the field had to be done at nights or on weekends because of the traffic in this area. So they had actually figured that
15 days would probably take them a couple of months to obtain the data. And it was done 6 days, 1 day in the field, again, flying that UAV for about 20 minutes, and then anchoring the control points. They had to do a little traverse, I would imagine, around the area to get that control. And this was kind of neat because they actually took some older surveys and projected them onto they were updating some as-built plans, but they were able to project the old information onto the images to see what had changed or hadn't. So we're talking 27 images, more control than you would use nowadays, because this is actually one of the earliest, an earlier project done with an older version of Datagram 3D that required more control. And they drew all the road and some of the buildings that they needed. Created, really, this doesn't show it because they exported it to CAD. This is just one small section of it. Finished their plans on their as-builts. Okay, so just another example, and again, that one does not look, I think it looks a little higher than 50 feet. Doesn't say here how high it was. That one looks like it's more, probably like 70 feet, getting a larger area, that's why. Summary, I want to wrap this up. The revolution in digital photography is really changing the way land surveyors are now working, because you can now measure and draw directly on images. And the one tool that makes that the most efficient way to do that is UAVs. Really a highly effective way, profitable way of gathering the data that you can then put into a photogrammetry software solution like Datagram 3D and get full 3D results. Just again, I want to thank DataMate for hosting this with me. They are the world's leading field-to-plan software suite, making land surveying work easier, faster, safer, and with superior accuracy. You can visit www.datamate.com to learn more about Datagram 3D and their other products. I'd like to invite you. The next DataMate Live webinar is planned for next month for November 20th. I think initially we were going to highlight a couple of new case studies, which we may still do. I'm going to put to be determined, because we may also, in addition, or maybe separately, we'll see, have a webinar on the newest version 4.0, which really has some great features built into it. So it'll either be one or both together. So please, put that on your calendar. We'll be sending you out announcements for that. That'll be November 20th, 2014, same time as this webinar, 2 p.m. I guess that'll be Eastern Standard Time then. I think we switch over. Daylight savings time ends where I'm hosting the webinar. But we'll let you know the details. On the bottom of the screen here, I'd like to point out that there's a contact information for DataMate, phone number, and you can email inquiries@datamate.com. My information is over on the right-hand side. I'm Eric Colburn, PLS President of Colburn Strategic Partners. And I'd like to give, yes, I didn't have it in here. I'm sorry about that, but I'd like to give a thank you to Dr. Jaroush and Chaim Zelikoski, co-founders, CTO and CEO, for helping me with this presentation, and also GeoBlue Services, which helped me with some of the data and information on the UAVs. I do see we have a bunch of questions about the webinar. I'm going to be chatting and try to answer your questions. If I don't get to them all, we will be providing the recording of this, and so that might take me a day or two to get that process, but that'll be going up online as well, so you can re-watch it or share it with other people that you think might be interested in it. We would greatly appreciate that. So I'll be hanging out. I'm going to stop the recording in a minute, but I will be hanging out for just a little bit longer, as much as you need. I have no place to be. If you have any questions, we can chat about it. And definitely feel free to contact me or DataMate if you're interested in learning more about surveying with UAVs and or Datagram 3D. I want to thank you for your time out of your day. We appreciate it very much. Thank you. Work smart and be brilliant. And hopefully we'll see you next month, November 20th.